Next up we have Kara Wyatt, and Kara is going to be talking about Tibble 2. I actually know that's how you say that. Tibble 2, your friendly neighborhood flu fighter. Kara.
Are you afraid of needles? For me, it always hurts to get a shot. And in a study conducted in 2012, it showed that roughly 23% of people actually avoid their yearly flu vaccine because they're afraid of needles. This is a high number, but it's not surprising given the current anti-vaccine climate. Some people believe that vaccines cause autism. They don't. And others believe that we don't even need a vaccine. And we do, because vaccines not only protect you, they can protect everyone around you as well. Many of these issues with vaccines can be easily solved by just talking to your doctor. But what do we tell people who are afraid of needles? Well, we basically tell them to suck it up, because you can either get the flu shot or potentially suffer the consequences of actually getting the flu. There is one other alternative though, and that's through the use of the intranasal flu vaccine. This vaccine is administered exactly how it sounds. It's a vaccine spray given within the nostrils that should confer all of the protection of the flu shot without the pain. That's not exactly how it went, though. For the 2016-2017 flu season, the intranasal flu vaccine was removed from the market because it was so ineffective. That's why one of my research goals is to potentially find a way to increase the protection in the intranasal flu vaccine. The way that we hope to do this is by understanding the role of the protein Tibble2 within the lungs during an influenza infection. Tibble2 has already been shown to have many different immune functions. Specifically, when Tibble2 is present, it can actually decrease susceptibility to listeria, tuberculosis, and other parasite infections. Therefore, we believe that studying Tibble2 in the context of influenza makes sense. The way that we're actually studying this protein is by isolating the main targets of influenza, infecting those cells with virus, and then analyzing the activity of our protein during the early hours of infection. The reason why we're looking at the early hours of infection is because this is the time of the innate immune response. The innate immune response is initiated within the first seconds, minutes, and hours of infection. You can imagine your innate immune response being very similar to an EMT or police officer coming to the site of infection to help control the infection. Therefore, we're trying to understand how Tibble2 is able to control the infection. So far, our results have been promising. We've seen that when the protein is actually present, it can lower death rates and decrease symptoms. There's still a lot of work to be done in both understanding the role of Tibble2, specifically within the lungs, and even more work before we can move forward with any vaccine studies. So please, continue to get your yearly flu shot, but just know that we're trying to make flu season a little less painful for everyone. Thank you.